Hi, hello, good morning, my dear friends and students. Welcome back to Ravi Math Space. Today we are going to learn and discuss very most important topic, that is theorems of decimal expansion of rational numbers. Actually, we have three theorems are there. Out of three theorems, one of them is let x be a rational number whose decimal expansion terminates, then x can be expressed in the form of p by q. In the form of p by q, where p and q are coprimes and the prime factorization q is of the form 2 power n into 5 power m, where n and m are non-negative integers. If we learn these three theorems 100%, we will get minimum 2 marks or 3 marks in the examination. 2 marks or 3 marks. Okay, now one theorem we are going to discuss very clearly and detailedly. Okay. Observe careful and read the theorem careful and understand the meaning of the theorem. If you understand the meaning of theorem means we can do problems very easy. Okay. So once you see here, careful here. Let x be a rational number whose decimal expansion terminates. Already we know. What we know here? Every rational number should be consist either terminating decimal expansion or non-terminating decimal expansion. This theorem talking about terminating decimal expansion. When we have a terminating decimal expansions, that decimal we can express in the form of p by q. In the form of p by q, where p and q are coprime numbers, and the prime factorization of q means denominator is of the form 2 power n into 5 power m. This n and m are non-negative integers. This is the theorem. Now, based on this theorem, I will explain some problems. You can understand the very easily. Okay. Suppose, first what we should take? One decimal expansion. Suppose if I take one decimal number, which type of decimal number? That also terminating decimal. Okay. These terminating decimals we can express in the form of p by q form. How means see procedure. So 2.5 is a terminating decimal expansion, terminating decimal. Okay. Now 2.5 is a decimal number. This decimal number we should convert into whole number by multiplying suitable special numbers. What are the special numbers? So 10, 100, 1000 and so on. Meaning is multiples of tens. Meaning is multiples of tens. Such type of numbers are called as a special numbers. Okay. Now see, careful observe here how I am writing here. 2.5 I can write as a 2.5 into 10. Why reason? I am taking only 10. Why? Because 2.5 is a decimal number. This decimal number we should convert into whole number by multiplying suitable special number. Why, sir? Here we should multiply only 10, not 100, not 1000. How to take this number, special number, either 10 or 100 or 1000 or whatever number, based on the decimal places in the decimal number. See here, 2.5 is a decimal number. We have a 1 decimal place. We have a 1 decimal place. That's why I am taking here only 110. Suppose here in the decimal number we have 2 decimal places, means we should multiply with 100. Meaning is what here? How many decimal places consist in the decimal number, that many times we should multiply with 10. That is the logic here. Here only 1 decimal place, that's why I am taking only 110. So if I take 110 here, numerator means denominator also we should take 10. Why we should take? Reason. Why? Because here we are applying equivalent rational number condition. Okay. Now what you will get answer here? 2.5 multiplied with 10 means we will get 25. So denominator is here 10. 10 as it is will become denominator. So if I do again simplify it, you will get 2.5 answer only. Yes or no? So 2.5 multiplied with 10, you will get 25. Actually we have a one special case is there. When we are going to multiply decimal numbers with special numbers means, so if I multiply means the point jumps towards which side? Right side. How many times if you multiply means that many places it will be jumps. Here only 110 we are multiplying means to decimal number. One place jumps towards right side. So it becomes as a 25.0. 25.0 we can write as a 25. So denominator as it is. Here nothing is there means 1 is there. 10 into 1 which is nothing but as a 10 only. So 25 by 10. Now this is fraction in the form of P by Q. So decimal number, terminating decimal number, now we converted into P by Q form, that is rational number. So rational number condition is what here? So numerator, denominator should be coprimes. P and Q are coprimes. Can you tell me 25 and 10 are coprimes? Not. Why? Because we have a here common factor is there. What is the common factor here? 5. Now divide with 5. 5 5 is 25. 5 2 is 10. What you will get there? We are going to get the answer is 5 by 2. We are going to get the answer is 5 by 2. Now 5 and 2 are means P and Q are coprime numbers. Coprime numbers. Up to where finish? Up to here finish. Next one is what here? Next one. So the prime factorization of Q is of the form 2 power n into 5 power m. Now see here, this I can write as a already here 2. So denominator is of the form, how it is? 2 power 1 into 5 power m. Actually here condition is 2 is there. How? Here only 2 power n only there. Where is 5s are here? 5 power m. So 1, actually here 2 I can write 2 into 1. Okay. Now it is 2 power n. It is 2 power n. Now 1 I can write as a 5 power 0. N I can write as a 5 power 0. 5 power 0 is nothing but automatically it is for as a 1 only. Therefore Therefore, denominator. What is denominator? 2. Denominator is of the form. Which form? 2 power 1 into 5 power 0 means nothing but as a 2 power m 5 power, sorry, 2 power n 5 power m. So 1 and 0. Already n and m are non-negative integer. Can you tell me 1 and 0 are non-negative integer or not? Here n is equal to 1, m is equal to 0. Therefore 1 and 0 are non-negative integers. This is the meaning of the theorem. This is the meaning of the theorem. In the examination, how they will ask the question? See here. Express, in the examination they will ask the question. Express decimal expansion in the form of P by Q. This type of questions may get as a 2 marks or 3 marks in the examinations. Very most important topic. So this theorem, if you learn, means 100% you will get the 2 marks or 3 marks in the examinations. Okay, I hope you understand the concept of this one. One more, some more problems we will discuss based on this theorem. You can understand better here. Okay, if you want to means take the screenshot. Some more examples we will discuss now. You can understand the better theorem. Okay. Suppose if I take 0.4 is a terminating decimal. 0.4 is a terminating decimal. This terminating decimal we can express in the form of P by Q. How means see here. Yes. So it is a decimal number, convert into whole number by multiplying suitable special numbers. So in the decimal number we have only one decimal place. That's why we should multiply with this decimal number numerator. How it is? We can write here 10. So denominator also 10. Equivalent fraction, equivalent rational number conditions. Numerator, denominator, you should take the same number only. Then only equivalent condition is satisfied. Okay. Now what you will get answer here? 0.4 into 10, which is nothing but as a 4. Now 10 into here nothing is there means 1 is there denominator. So 10 will get. Now 4 by 10. Now in the form of P by Q it is. But it is not a coprime number. Numerator number, denominator not a coprime number. 4 and 10 are. These two numbers should not have another common factors except 1. But 4 and 10 are common factors are there. What it is? 2. That's why 4 and 10 are not a coprime numbers. Now this 4 and 10 are divided by 2. So cancel it. 2 2s are 2 5s are. What we are going to get now answer is 2 by 5. Now 2 and 5 are coprime numbers. Why? Because 2 and 5 does not consist any other factors except 1. Now it is in the form of lowest form of the rational numbers. Now 2 by 5 is called lowest form of the rational number. Lowest form of the rational numbers. Okay. It is 1 mark. Next what it is? The denominator is of the form should be in the form of 2 power n into 5 power m. So this I can write as a 2 by 5 power n into 2 power 0. So we can conclude that denominator 5 is of the form, how it is? In the form of 2 power n into 5 power m. What are the values of m and 1 here? m is equal to 1, n is equal to 0. These 1 and 0 are non-negative integers. Therefore, our answer is 2 by 5. Our answer is 2 by 5. Understand here. This process is called converting decimal numbers into rational numbers. Converting decimal number into rational numbers. One more problem we will discuss. Suppose if I take terminating decimal 0.115. This terminating decimal we should express in the form of P by Q. Yes. How to convert? We have some procedure. What is the procedure here? Very simple. We should multiply with this decimal number suitable special number. Now can you tell me what is the suitable special number here? So if you want to multiply, if you want to take the suitable special number, means first we have to see the how many decimal places consist the given decimal number. So here 1, 2, 3. This decimal number consists 3 decimal places. That's why we should multiply with 10, 10, 10, which is nothing but as a how many decimal places? 3 decimal places. That many times. 3 times we should multiply with 10, which is nothing but as a we are going to get the answer is 1000. So here numerator 1000 means denominator also 1000. We have to satisfy the equivalent conditions. Then only the volume should not be changed. Now what we should get answer here? So 0.115 if I multiply with 1000 means we are going to get the answer is 115 upon. So 1000 as it is will decay. Why? Because here denominator nothing means 1. 1 into 1000 is 1000. Now see, here it is in the form of lowest form or not? No. Why? Because 115 and 1000 should be divided with 5. Yes or no? Yes. Now with the divide, 5 to 10, 5 3 is 15, 5 to 10, 2 zeros as it is. The remaining answer is 23 by 200. Now 23 and 200 does not consist the any common factors except 1. Therefore, it is the lowest form of the rational number. Lowest form of the rational numbers. So, after again we should check out denominator is of the form 2 power n into 5 power m or not. Now take denominator is what here? 200. What is the prime factorization of 200? See, we can write here. 2 ones are 200, 2 50s are 2 25s are, so 5 5s are. So what is the prime factorization of 2 into 2 into 2? 5 into 5 into 5. So we can write 2 cube into 5 square, unique factorization. So 200 prime factorization is in the form of 2 power n into 5 power m. So it is in the form of 2 power n into 5 power m, where n and m values what here? 3 and 2 respectively. N and m values are 3 and 2 respectively. Understand here? Okay. Now if we observe these 3 problems, first problem we will get only 2 is the denominator. 2 is denominator means how we can write here in the form of means already you have seen here. Now here in the second example we got here only 5. There is no 2. But we can write how? So 1 I can represent 2 power 0. So it is in the form of 2 power n into 5 power m. Now here see. Here in third problem we got here two prime numbers, 2 as well as 5. Meaning is, what we are going to conclude here, denominator decimal expansion should be either 2 or 5, both 2 and 5 only, not other factors, then only it will be terminates. That you are going to understand here. So I hope understand the theorem 1 concept. In the next video I will explain theorem 2. Okay, until take care, bye bye.